So now that we know about lines of best fit, we're going to mix that with graphing that we did in the previous chapter. So we'll graph, we'll have to maybe answer some questions, but then we'll also now fit a line of best fit to those data points. So this is called interpolation and extrapolation, and we'll see that in a minute. But I like to see it just how it works in the question. But first, interpolation, that's when you're estimating, you're guessing, right? So estimating, or you can think of it as guessing, because it's just our best guess. We're guessing of a value that's between something that we know. And that might seem a little vague right now, and that's okay. Extrapolation is also guessing, so we're going to be guessing at some value beyond what data we know. So, and this is data beyond, yeah. So beyond is, whoops, I wanted to do that in yellow, but clearly that is not an option. Here we go, beyond. So for instance, and I'll try to draw a little graph here. If we've got some data here, we might want to guess what's going on in between. There's this kind of this hole here. So we want to guess what is going on in between there. And that's called interpolation. I don't know if I spelled that right. But we also might want to guess what the heck is going on way out over here, beyond. So this is going to be our guess for extrapolation. Okay, so interpolation is guessing in between. So I've got some data over here and some data over here, and I want to guess what's happening in between. That's why inter, in between. But then I want to go extra. That's going above and beyond. Extrapolation, that's going past what we're looking at. So we got our data here, but now we want to see what's going on beyond that. Okay, here, so let's take a look here at the first one. During a science experiment, students mixed acetone and chloroform, which generated exothermic reaction. Well, I don't know what any of this means. The students recorded a temperature of the mixture as it cooled. So it was hot, and then it cooled. And it wants us to create a scatter plot. So at 30 seconds, it was 29.6 degrees. Then went up 29.9, and then, so you can see here, it went up 29.9. And then it went 29.5, so then it dropped. And then it dropped. 29.2, went up, went down, went down, went down, went down. So it looks like it's, the temperature is cooling. So it's kind of nice to know what the overall trend is before you graph it. So I need to take a look. 30 seconds, and I need to do 29.6. Okay, well, 29.6. I'm trying to zoom out here. Okay. It's actually extremely difficult to do this on the tablet. So every single one of these looks like 30 seconds. So the very first one must have been, and I'll draw it here, but this must have been a 30. Because the next one's a 60, then this is a 90. So you can keep up with the pattern if you want, but I'll just stop there. And then, I don't know what's going on here. 26 to 27. How many spots in between? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay. So this looks to me like 26.1 and then 26.2. So it kind of goes up like that. So it's always 0.1s. Well, that's good to know. So I'll just put 26.1 as just as a reminder so that I know it goes up by 0.1s. And so at 30 seconds, we are at 29.6. So here's 30, and here's 30. That's 29, and then 0.6. So 1, 2, 3, 4, 5, 6. Right? So I'm not going to do this every time, but this is 29.1, 29.2, 29.3, 0.4, 0.5, and this would be 29.6. So that's where that is. So at 30 seconds, we go all the way up to 29.6. And then at 60 seconds, we go up to 29.9. So 60 seconds is the next one over. And then the next line is 90, which I need, and then 120, which okay, so it looks like we're going to go one line over every time, unless I skip something, I don't know. So at 60, you go to 29.9. So this line, 29.9, you go 29 right there. So just before 30. And then at 90, you're at 29.5. So at 90 seconds, you're on this line, and you got to go up to 29.5. So that's halfway in between. And then at 120 seconds, so that's this line, I'm pretty sure. I'm just going to zoom out a bit here. And that was clearly too much. So at 120 seconds, yep, that's the line I'm at. I need to go to 29.2. So here's 29.1, and then 0.2 is right there. So 29.2. And then I have to do 150 seconds, which is 29.4. So that would be the next line. Here's, and then 29 is right here. 0.1, 0.2, 0.3, 0.4. So you're going to have to be graphing this and just paying attention. Make sure you count properly. At 180 seconds, is that the next line? Yeah, I'm good. I have to go 29.1 to 29.1. And then 210 seconds, which is the next line, I have to go to 28.7. So this one right here should be 210. Yeah, that's what I'm looking at. And it's 28.7. So 28.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So 28.7. The next line is 28.6, which is one lower. Oh, then 28.5 is the next line, and then 28.3 is right there. Okay, so that's what it looks like. And I'm just going to make sure 28.1, 0.2, 0.3. Perfect. Okay. So what do we have to do? Create a scatter plot. Okay, looks like I've done that. Some of my circles look pretty terrible. I don't know how to make it look any nicer other than just making them larger. Okay, so what's the next question? What does the zigzag on the x-axis mean? Okay, so what does this mean over here on the x-axis? Oh, it's not, it's on the x-axis, but actually what it should say is on the y-axis. So that's an easy enough change for me to make here. So what does the zigzag on the y-axis mean? And if you look at the x and y-axis, you can see the x-axis here, which I'll highlight. That goes down here, so 120, 90, 60, 30. So every mark is 30, and then it goes to 0. So there's a really nice pattern, 0, 30, 60, 90. It always goes up by 30. And then you take a look at the pattern this way. So 27, 26, 0. So the zigzag indicates that this graph, this jump here, is not like a proper jump. We don't go down with a really nice pattern. So this jump here goes from 27 to 26, and you think this would go from 26 to 25, but it doesn't. It jumps right down to 0. So the zigzag means that we've just jumped to 0. So that's all that it means. The next thing we need to do now is draw a line of best fit. So I've got my line here, and I could just bring this up. Actually, I'll probably try to zoom this out a little bit here. Nope, that's not going to work. So I'll move this, and I'll move this. So I want to start kind of here, and I want to follow this line. Now, one of the things that you need to remember when you're drawing lines of best fit is that you want to go to the end of the graph. So I kind of have to shoot all the way to the end. And now what I want to do is count how many do I have above and how many do I have below. So above this line and below this line. Let's see here. So I've got 1, 2, and 3 that are above, and then below I've got 1, 2, 3 Oh, maybe. So I can, it looks like I have 4 below, but I can probably just change this ever so slightly to do something like that. And I'll just zoom it in here. So let's take a look at the top. I got 1, 2, 3 above. And below the line, I got 1, 2, 3. But even that's kind of touching. So I should maybe adjust it, fine tune it, and I went maybe a little too far down here. So the line that you're going to create is going to be slightly different than mine. And that's okay. So the answers you get to some of the questions will be slightly different. So that looks good. I mean, this 4th point is kind of iffy, but I think that's going to be okay. So that's our line of best fit. Draw the line of best fit. Done. And then it says predict at 100 seconds. Okay, so we want to predict at 100 seconds. So it's, yeah, 100. So let's draw here just to see. So these go up by 30, right? So this is 30, 60, and then this would be 90. So 100, I don't know where 100 is. 100 is somewhere in between here. So maybe this is 100. Right? So maybe this line, which I'll write down here, maybe that's 100. Because you know that this spot is 90. And so we want to predict what is the temperature after 100 seconds. And so what you want to do is you want to grab a ruler and you want to go all the way up until you hit your line. So let me just, I got to zoom out quite a bit here, and I need to get a line. So I drew a straight line here at 100. It goes all the way up until I hit my line of best fit, and then I'll draw a line all the way over to here. And that will give me a bit of an idea of what is the temperature at 100 seconds. So I'm just going to draw a couple couple points around it. 29.1, 29.1, 2, 3. So this one right here is 29.4. So this right here, I don't know. It's kind of like 20. It's just above 29.4. So this is, and we're just guessing here. So even though it's above the line, I'm going to say it's approximately 29.4. Now yours that you do on your drawing might be 29.5 or 6, or might be 29.3 or 29.2, just depending on your line of best fit, because we're just guessing, right? That's what I told you at the very beginning. When you interpolate or extrapolate, you're just guessing. You're guessing based on this line that you created. So I've guessed using mine. I did 100 seconds. I used a ruler to go all the way up till I hit my line, and then I went over. And so I guess that it's approximately 29.4 degrees. And then it wants to know, is it interpolation or extrapolation? So if we started from 0 to 300 seconds, that's what we're looking at, 0 to 300 seconds. If you find something in between, like I did, we found 100. 100 is in between. Therefore, it's interpolation. Now, if we found something over 300 degrees, then that would be extrapolation. So we need to, I just want to write a little nicer. This is interpolation. So if I'm looking for, if I'm predicting or guessing something out of the 300, then we're looking, oh, it's right here. Predict the temperature after 390 seconds. So we're at 0 to 300 seconds. That's what our data, this is what our data said. This is what our data is calculating from 0 to 300. So then we're outside of that. We're outside. We're beyond. Or we're something extra. So that would be extrapolation. So we need to actually predict that. What is it? Approximately what? So let's do 390 seconds. So we got to create a line again at 390 seconds. So that's kind of nice. These go up by 30. So this is 360. This is 390 right there. I'll make the line go down like I did the other one. So that is 390, so I can just follow along that line. So I'm going to draw a ruler and go up, and then we'll see where we're at. So you can see I've used a ruler and gone all the way up here at 300, is it 390? Yeah, 390 seconds. And then I'm going to try to do this. Yeah, so there's 390 seconds. I went all the way up and then went over, and now I need to figure out where did I land. So, I mean, this is 28. Down below would be 27.9, and then down below would be 27.8 because it goes down by 0.1s. So we are predicting at 390 seconds, we're at 27.8. So 27.8. And if you take a look, if I zoom out enough, you can see that 390 seconds is past. Like you can see right here. Oh, what color did I have those? Yeah. Interpolation was me predicting somewhere in between. And you can see all of my data is right there, and this blue dot is in between. But then I've extrapolated at 390 seconds, and that's a piece of information there's my data. It's now beyond that. It's something extra. So just keep that in mind. Now let's take a look at what do I have for predict how long it would take for the solution to cool to 27 degrees. Is this an example of interpolation or extrapolation? Okay, so here I started for D and for E, I started by looking at 100 and looking at 390 and drew a ruler up until I hit my line. But now I'm going to be looking instead at 27. So I want to draw a line from here and draw it all the way over to see when I hit my line, and then I can calculate the time. So let me draw that line now. So you can see here that I've now drawn a line at 27. At 27, I've drawn a line, a ruler line, till I hit there, and then I can predict that it's going to take around 540 seconds. Okay, so how long will it take for the temperature to reach 27 degrees? Well, according to my line of best fit, I would say 540 seconds. So I just need to write that down. 540 seconds. Is that interpolation or extrapolation? Okay, so I say approximately 540 seconds. Don't forget the units, in this case it's seconds. So I got it down. Zoom out. Is this point here interpolation or extrapolation? Is it in between the data or is it extra? And you can see my data is here. It's now beyond that clump of data, so I would say it's extra. So we need to write extrapolation. Extrapolation, yeah. I realize this video is really long. There's only one example basically for the whole unit, for the whole chapter, and then after that, there's 3 questions for you to try. So now we predicted here, we predicted 27. Now we're going to be predicting 29.2. So how long will it take to reach 29.2 degrees? So I need to go up to 29.2. So here's 29.2. I'm going to draw a line and then go down here and see if I can figure out how long this will take. I've drawn my line here and went over. This is 29.2. Went over until I hit my line of best fit, and now I can look down and see where do I land. There's 120. This is 150. So it's just a little bit before. So I don't know what that is. You can say approximately 150, or you can say approximately 145. Again, we're kind of just guessing. Approximately 145 seconds. And it wants to know, is that interpolation or is it extrapolation? So is it in between? Is that point that we looked at in between, or is it outside? And so again, here's my data points, and then here's the one that I found. And it looks to me like, yes, it is indeed in between my collection of data, so I would say it's interpolation. So you can see the 2 that I have, two that I have right here, they're inside, so they're interpolation, and these two are outside, so they're extrapolation. So yeah, I'll label this as interpolation. Interpolation. If I can actually zoom in anymore. Nope, impossible. Okay, interpolation. All right, so again, this is one question. This is one of the biggest parts of this test of this unit. It's been able to get a bunch of data, plot it, create a line of best fit, and then just start guessing, which we call estimating. So we start estimating a bunch of things, and then you need to know if that estimation is an interpolation or an extrapolation. So this is a really good question, and there's a bunch of worksheets for you to do after.